nonlinear inequality, section 2.7. Okay, and for nonlinear inequalities, since they're not linear, we have to set up test intervals. Okay, so there's 3 things that we do to set up our test intervals. The first thing we do is that we solve our function to find our zeros. So usually that involves factoring if we're talking about a quadratic. So we'll factor and find our zeros. So the next thing we need to do is we need to put them in order from smallest to biggest. And then we group them so that we can test one number inside the interval. Get started again. Okay, so if we look at the polynomial x squared minus 2x minus 3 is less than 0, I'm going to note that if it's less than 0, that means we're looking for negative answers. Okay? That will come in handy at the end. So we'll note that. And then the first step we said was that we had to solve this for our zeros. Okay, so I'm going to factor it. So my factors of 3 that subtract give me negative 2 are 1 and 3. So 1 minus 3. So I have x plus 1 and x minus 3 when I factor it. And I set that equal to 0 to find my zeros, which then tells me that my first 0 is at negative 1 and my second 0 is at 3. Okay, step 2 was to put them in order, which they actually already are, and then we have to group them. Okay, so we're going to group negative infinity to negative 1, negative 1 to 3, and 3 to positive infinity. Okay, so you always group the 2 numbers together, and then you group them, one with negative infinity, one with positive infinity. Okay, and then our third step was to pick numbers and actually test them in our inequality. So, what's some number in between negative infinity and negative 1? Negative 2. Okay, so we'll test negative 2. What about in between negative 1 and 3?
2.
2. And between 3 and infinity? 4. Okay, so those will be our numbers that we're going to test. And we're going to test them by plugging them into this inequality and checking to see if we get a negative answer, because negative answers are what we're looking for. So if I plug in negative 2, then I get negative 2 squared minus 2 times negative 2 minus 3. Okay, and negative 2 squared is 4. Negative 2 times negative 2 again is 4. So I get 4 plus 4 minus 3 when I simplify, which just gives me 5. And 5 is positive, so I know that I don't have any solutions in my interval negative infinity to negative 1, because the number I tested did not give me a negative number. So if I start with then 2, know that I'm going to get 2 squared minus 2 times 2 minus 3. So 2 squared gives me 4. Negative 2 times 2 gives me negative 4 minus 3, which gives me negative 3, which is a negative number, so it is going to give me a solution to my inequality. And then the last number we're going to check is 4. So I'd have 4 squared minus 2 times 4 minus 3. 4 squared gives me 16. 2 times 4 gives me negative 8 minus 3. So what does 16 minus 8 minus 3 give me? 5, which is not negative. So we have a solution in our last test interval 3 to infinity. So then the last thing I'm going to do is I'm going to graph this on a number line. Oh, I meant to do that in black, but that's okay. So I needed negative 2, negative 1, 0, 1, 2, 3, 4. Okay, Okay, and I chose -2 to be my first number because that was the number I tested, and 4 to be my last number because that was the number I tested. Okay, and then I know that it falls in between -1 and 3, so I know that I'm going to be shading in between -1 and 3. And then we represent our endpoints with little parentheses. So I'm going to put a little parenthesis at 3, a little parenthesis at -1. So I know that my interval that solves that inequality is anywhere from -1 to 3. Okay. Okay, so let's do another one. So we've got x squared minus x minus 6 is less than 0. Okay, and we need to figure out when that's going to give us positive solutions that work. And so less than 0 tells me that I have negative answers. Well, come back. Where'd you go? Try again. So negative answers. So the first thing I'm going to do is I'm going to find my zeros. So if I factor this, my factors of 6 that subtract to give me -1 are going to be 2 minus 3. So I get x plus 2 and x minus 3 to be my solutions. So I set that equal to 0. So I know that my first 0 is at -2, and I know that my second 0 is at 3. Okay, and then the second thing we did was we grouped them. Okay, so we always start by grouping with a negative infinity. -2 comes next in order. Then I know that I grouped my two solutions together, so -2, 3 get grouped together. And then lastly, I group one number with positive infinity, so 3 and positive infinity. Okay, and then the third step was to pick numbers that were inside these test intervals. So what's a number in between negative infinity and -2? -4. Okay, and what about in between -2 and 3? 0. Okay, and in between 3 and infinity? 4. Okay, so we've got test points of -4, 0, and 4. So I'm going to plug those into my inequality. So I get -4 squared minus -4 minus 6. Well, this minus a negative becomes a plus. -4 squared is 16. So I get 16 plus 4 minus 6, which gives me what? 14. Okay, so I know that which is positive, right? And we're looking for negative answers. 14 is not less than 0, right? So we don't care about that interval. If we look at our second interval, we're testing 0, so 0 squared minus 0 minus 6. Well, 0 squared is 0, minus 0 minus 6 gives me -6. Okay, which is less than 0, so that is in our test interval. And then the last thing we're going to look at is testing 4. So 4 squared minus 4 minus 6. 4 squared is 16, so 16 minus 4 minus 6. And what's that going to give me? 6, which is positive, so we don't care about it. There will be times when you will get more than one interval to work, but in this case we only got one. So the last thing we're going to do is we're going to graph it on a number line. So if I get my number line, the first number I care about is a -4. -3, -2, -1, 0, 1. 1, 2, 3, 4. Okay, and so I know that my interval is in between -2 and 3, so I'm going to put my parentheses at -2 and 3. And then I know that I need to shade in between those. So it could be any solution point could fall in between negative 2 and 3. Okay, does that make sense, or do we want to do another one like that? Okay. So let's look at example 5. Okay, so we get 2x minus 7 over x minus 5 is less than or equal to 3. We're going to do similar stuff where we need to find our 0. But the first thing that we're going to need to do is we're going to need to get this to make it easier. So we need to move the 3 to the other side because we have to compare it to a 0. Okay, so this side always has to be equal to 0. So 3 minus 3 is 0. So we get 2x minus 7 over x minus 5 minus 3 is less than or equal to 0. But that doesn't really help us because this still isn't very simple. So I'm going to need to make this have common denominators in order to subtract. So I'm going to need to make common denominators of x minus 5. So I need to multiply both the top and bottom by x minus 5. That will give us common denominators. So I get 2x minus 7 over x minus 5. This is like 3 over 1. So 3 times x is 3x. 3 times 5 is 15. And the negative times a negative gives me a positive. 1 times x is x. 1 times 5 is 5. Okay. So now that we have common denominators, now we can compare and combine. So 2x minus 3x gives me negative 1x. And negative 7 minus 15 gives me negative 22. All over x minus 5. We subtract them just as if it were like having numbers. So I'll get a final comparison there of negative 1x minus 22 over x minus 5. Okay. So once I get there, then I can solve the top and bottom to give me my test intervals. Okay, so negative 1x minus 22 equals 0, and x minus 5 equals 0. Those are what's going to give me my test intervals. So if I solve this top one, then I get x is equal to negative 22. If I solve the bottom one, then I get x is equal to 5. Okay, so this was part number 1. Second part is grouping them. So I'm going to group them by grouping them negative infinity to negative 22, just like we did with the first ones. Negative 22 and 5, because they're in order. And then 5 to infinity. And the third part was just testing them. So since we're looking at less than 0, we're looking at negative numbers. What are some numbers in between negative infinity and negative 22? Negative 23. Okay, what about in between negative 22 and 5? 1. In between 5 and infinity? 6. Perfect. So those are going to be the numbers we're going to test. So if I plug them into this simplified equation, I get negative 1 times negative 23 minus 22, all divided by negative 23 minus 5. Well, negative 1 times negative 23 gives me positive 23. So I get 23 minus 22, and negative 23 minus 5 is negative 28. So 1 over negative 28, which is a negative number, right? So this one works. Okay, so then if we look at 1, we get negative 1 times 1 minus 22 over 1 minus 5 Well, negative 1 times 1 is negative 1. Negative 1 minus 22 is negative 23. And 1 minus 5 is negative 4. And the negative divided by a negative gives me a positive, so it's going to be positive 23 over 4. Which doesn't work, right? Because we're looking for negative numbers. The last thing we're going to do is we're going to look at 6, because that's my last test interval. So I get negative 1 times 6 minus 22, and 6 minus 5. Well, negative 1 times 6 is negative 6. Negative 6 minus 22 is negative 28. And 6 minus 5 is 1, which then when we simplify that, we just end up with negative 28, which is negative, so that works. Okay, so we have 2 test intervals that worked, which I told you could happen every once in a while. So I know that my first number that I need to include on my graph is negative 23, because that was my first number that I tested. Negative 22, 0, 1. I skipped those numbers because it would be a pain to write all those numbers, by the way. You can do that by writing a squiggly line. And then we go all the way up to 6. So 2, 3, 4, 5, 6. Okay, and then we're going to graph it. So I know that I have a point at negative 22. And it goes down to negative infinity, so it goes forever down. Okay, and then I also know that I have one at 5. That was my next interval, and that goes up to positive infinity. So this graph would look like that with arrows going opposite directions. Okay, so let's do one more like that, just since it's harder when you have to simplify and rationalize your denominators. So we're given 3x minus 5 over x minus 3 is less than or equal to 1. Okay, so we need to solve this for 0, so I'm going to subtract 1 from both sides. These ones then cancel, give me 0 is less than or equal to minus 1. Okay, and in order to do that subtraction, we have to have common denominators. So I'm going to multiply everything on that 1 by x minus 3, and I'm going to change that 1 into a fraction of 1 over 1. So then we're going to multiply, so 3x minus 5 over x minus 3 minus 1 times x is 1x. 1 times 3 is 3. 1 times x is 1x. 1 times 3 is 3. Oh, you're right. That negative and a negative turns into a positive. Yep, you're right. Good catch. So then if we simplify that, then we actually just do our subtraction. 3x minus x gives me 2x. Negative 5 minus 3 gives me negative 8 over x minus 3. And that all has to be less than or equal to 0. So that tells me that I'm looking for negatives. Okay. Yep. If it was greater than 0, then you look for positives. Most of the time it'll be less than 0, because that's how usually inequalities are written. Every once in a while, it'll be greater than 0. And then we just need to solve these two, top and bottom, to find my 0. So that's step 1, finding my zeros. So 2x minus 8 equals 0, and x minus 3 equals 0. Well, then this just tells me that x equals 3. And this one tells me that x equals 4. Okay, so we get our 2 test intervals of 3 and 4. And we actually have to write these in order. That's the second part, writing them in order and grouping them. So I know that I'm going to group negative infinity with my smallest number, which in this case is 3. What is going on? Okay. My next set of groupings is 3 and 4. And then my last set is 4 and infinity. Okay, so let's pick numbers in those to test. So what's a number in between negative infinity and 3?
2.
Okay, and in between 3 and 4? 3.5. And in between 4 and infinity? 5. Okay, this should be fun with decimals. Alright, so we're gonna plug them into this simplified equation. Okay, so 2 times 2 minus 8 over 2 minus 3. Well, 2 times 2 is 4, so 4 minus 8. 2 minus 3 is negative 1. 4 minus 8 is negative 4 over negative 1, which simplifies to positive 4. So this one doesn't work exactly. Okay, I plug in 3.5. 2 times 3.5 minus 8 over 3.5 minus 3. Well, 2 times 3.5 is 7. So I get 7 minus 8. 3.5 minus 3 is 0.5. And then 7 minus 8 gives me negative 1 over 0.5, which gives me negative 2. Which works, since we got a negative. So we know that we've got an interval of 3 and 4. The last thing that we need to check is number 5. So 2 times 5 minus 8 over 5 minus 3. Well, 2 times 5 is 10, so 10 minus 8. 5 minus 3 is 2. 10 minus 8 is 2, so I get 2 over 2, which simplifies to a positive 1. And that one doesn't work. So the only interval that works is in between 3 and 4. So if I draw my number line, I know that my first number starts at 2. So 2, 3, 4, 5. And my last number ends at 5. So I could actually just do a really short number line on this one, in between 2 and 5. And I know that I'm only in between 3 and 4, and I'm shading in between them because it was that in between something. Okay, so that's all you guys are doing today is those 3 steps. So page 13 through 22 and 41 through 50.